In this video, we are going to derive the cosine of 2x. So pretty much what the cosine of 2x looks like is, obviously it looks like that. So we're going to derive the cosine of 2x. So what is another way that we could represent this cosine of 2x? So we're pretty much going to write the cosine of 2x in terms of sine x, cosine x, and stuff like that. And that's the whole idea. We're pretty much just going to find an identical way to write cosine of 2x like that. And they'll probably teach you this sort of thing that I'm showing you in class of what the cosine of 2x is. And they'll show you how you get there as well. So that's just another thing. Now, we can all agree that the cosine of 2x can be rewritten as the cosine of x plus x. Because we know that x plus x is just going to result in 2x. So that makes sense. But really what this is it tells us that it's written in terms of the cosine of two angles added together. And so this is like the angle sum identity for cosine. So we could think of it as the cosine of two angles added together, like alpha and beta, right? Any two angles added together. And we know another way to rewrite this. It's just the cosine of alpha cosine beta minus the sine of alpha sine beta. And yeah, it turns out that that's the way that we can rewrite this into this. Now, if you're really not sure where this comes from, like you don't know, if you're curious about why this is true, I have a video on where I derive the cosine of alpha plus beta and find out why you can write it like this. And I'll put the link in the description if you want to see that. And so yeah, you guys are probably familiar with this as the cosine angle sum identity. And so yeah, this will result in this. Now, in this case, we're doing x plus x. So as a result, alpha and beta both equal x. So I'm just going to kind of write that down. Alpha equals x and beta equals x. So we're going to substitute both alpha and beta for x. So what we're going to get is we're going to get the cosine of x minus the sine of x sine of x. And so yeah, that's pretty much what we get. And so all we have to do now is we're just going to pretty much simplify this. Cosine x times cosine x is cosine squared x. Sine x is sine squared x. And that is it. That is another way in which we could write the cosine of 2x. So this is pretty much the identical way of writing it. That's it. But that's actually not quite it. This is an identical way to write cosine of 2x, but there are actually two other ways to write cosine of 2x. Notice how this identity, like this sort of expression, it looks really similar to sine squared of x plus cosine squared of x equals 1. All right, let me just write that down, because that's a very important note here. Actually, I'm going to write it this way. I'm going to write it with cosine first. So cosine squared x plus the sine squared of x equals 1. Notice how this looks really similar to this. And that's pretty cool. So why don't we apply this idea to this? So if we were to apply that idea to this, there are actually two cases that we could kind of get. I think we can go as far as up to there. So pretty much the idea is that cosine of 2x, if we were to substitute cosine, it's just cosine squared of x, we would get 1 minus sine squared x, and this is minus sine squared x. And simplifying this, we get cosine of 2x is equal to 1 minus 2 sine squared x. And so we could also express it equivalently like that. So that's also another way to express the cosine of 2x. And we could also do the same thing. Notice how we substitute cosine squared x for 1 minus sine squared x. We could do the same thing. We could substitute sine squared x for 1 minus cosine squared x. So let me just kind of show you. So the cosine of 2x equals, so we do cosine squared x, right? But this time we're going to substitute sine squared x for 1 minus cosine squared x. So as you can see, we already know that this would be identical to the sine squared of x. And simplifying this, right, if you were to simplify this, you are going to get to cosine squared x minus 1. So these two ways are just two additional ways of expressing the cosine of 2x. It's 1 minus 2 sine squared x or 2 cosine squared x minus 1. So these are the three identities for cosine of 2x, and it's pretty important that you know them. So I'm just going to show you one reason why you might use them. In fact, you'll use this quite a lot in calculus, actually like late calculus and early calculus too, but you'll have to know what sine squared of x is, or you'll have to be able to solve for sine squared x, solve for cosine squared x, because pretty much when we write sine squared of x, when we express that, what you're going to get is, if you were to solve for it, 1/2 times 1 minus the cosine of 2x. So that would be if you solve for that. Solving for cosine squared x, you'll get 1/2 times 1 plus the cosine of 2x. And these ideas are actually pretty important when it comes to integrating. So when it comes to integration, if you were asked to integrate sine squared x, even if you don't know what that means, when you're asked to solve a problem where you integrate sine squared x, whatever that means, it turns out using this identity is really important. So that's why it's really important that you know these. And so these are going to come back. And so it's really important that you know these identities, along with the one for sine of 2x in the previous video. But that's pretty much it for the identities for cosine of 2x.